Calculus is the study of change. The study of change. Now, what do we mean by change in calculus? In calculus, change refers to average rate of change and instantaneous rate of change. Now, when we refer to average rate of change, we often refer to, in a mathematical sense, the gradient of a line between 2 points on a curve. So, between 2 points. That's what you should remember average rate of change as. And we'll discuss it in a second. So, instantaneous often means 1 point. Now, this might seem counterintuitive. What does the rate of change of a single point mean in a function? But don't worry, we will explore this in a second. Now, let's say you had a function y is equal to f of x. This function can be any kind of function, doesn't matter what it is. But let's just say that this function looks like this. It looks like a normal concave down function. And let's say we have 2 points on this curve, one at x and one at x plus h. So if we define these 2 points, we can also define their y value, since this function is defined as y is equal to f of x. At the x coordinate x, our y value will be f of x, and our x coordinate x plus h, our y value will be f of x plus h. So, as I said before, average rate of change refers to the gradient between 2 different points. So in this scenario, it refers to the gradient between these 2 lines, which will mean the gradient of the line which goes through these 2 points. A formula for this gradient will be the change in the y values divided by the change in the x values, which will be f of x plus h minus f of x over x plus h minus x. X is cancelled out, we will get f of x plus h minus f of x over h. Now, we have just derived a universal formula for the average rate of change between 2 points on any curve. This can be any curve. Let's say you have f of x is equal to 12x plus 13 or whatever. You can use this formula to find the rate of change between any 2 x value points that you define. And you can sub those values into your curve, and using this formula, you will obtain the gradient of that line. And in a physical sense, we will explore this idea later as you study calculus. Now, let's try and explore the instantaneous rate of change. What does this mean? How can you have the gradient or rate of change at a single point on a curve? Now, what I want you to imagine is the tangent of a line to a curve. Let's say we want to find the gradient of this blue line right here. This blue line right here is tangent to the curve, meaning it touches it at a single point. Like if you have a circle, let's say, which looks like this, and you have a line which goes like this. This circle touches this curve only at a single point, meaning this line is tangent to the circle. That is what tangent means. So, what is the significance of this instantaneous rate of change? Now, let's try and find a formula for instantaneous rate of change. Ultimately, what I want you to focus on is that this line intersects is tangent to the curve at x. Now, what is the significance of this? Well, I want you to observe this. The limit as h approaches 0 of x plus h is equal to x. Now, what limit means? A limit is almost like an operator or a tool, meaning if we say the limit as h approaches 0, we say what happens when h goes to 0? What happens when h is as small as it could possibly be? Well, clearly, h will become 0, as we've said, meaning the limit as h approaches 0 of this function will be x. Well, this is useless and obvious, but, why am I telling you this? Well, the reason for this is, if we can take the limit of the average gradient function, or otherwise what we define as m, and we derive this formula, the limit as h approaches 0 of f of x plus h minus f of x all over h, then we have just derived a formula for what the average rate of change, the instantaneous rate of change at any point on a graph is. Okay, so, what have we just done? We've defined calculus as a study of change. There are 2 different types of rates of change, average and instantaneous. And the way you can find the average rate of change is by finding the gradient of a line drawn between 2 points, and that is your average rate of change between x and x plus h. Then we wanted to find a way to find the instantaneous rate of change at a single point. How do we do that? Well, we used our limit operator to derive a formula from our average rate of change formula. And from that, we have found the gradient of this tangent. And this is what is called the derivative in mathematics, which is often expressed as f of prime of x. And f of prime of x in any situation is equal to the limit as h approaches 0 of f of x plus h minus f of x. Now, the reason this formula is called first principles is because this is the very first principles of all of calculus. All of calculus stems from this single formula, and understanding this formula will save your life in calculus. You will almost understand 95% of everything you'll be taught in calculus, as it all stems back to this formula. This formula is your intuitive premise of the entire topic. Now, let's cover an example. Let's say we had a curve y, or f of x, is equal to 2x squared plus 1. And this curve is going to look like this. In our Cartesian plane, y is yx, xy. The curve will look like this at 1. If we want to find the gradients function of this curve, then we are finding a function which at any point in this function, we will get a constant term, and that constant term describes the gradient of the tangent of any point of this curve. So let's say our function, our derivative function is some, I don't know, let's just say it's anything. Okay, just imagine it's anything, and let's say it looks like this. It does not look like this at all, but just pretend it did. If we go here at this point, we want to find the gradient of the tangent to our curve at this point. We want to find the gradient of this line. Then we go to our gradient function, we substitute this x value in, and whatever the y value is, that physical y value is the gradient of this line. Now that is a mouthful to take in, so let's delve into it right now. Using our first principles formula, the limit as h approaches 0 of f of x plus h minus f of x all over h, we will equate this 2x plus h all squared plus 1 minus 2x squared plus 1 over h. Now, simplifying this, we get 2x squared plus 2xh plus h squared, which is the expansion of that quadratic, plus 1 minus 2x squared minus 1, because we multiply the subtraction into the brackets, over h, which is equal to the limit as h approaches 0 of 2x squared plus 2xh plus 2h squared plus 1, the 1's cancel out, minus 2x squared. I'll just rub that out. Okay, all over h. So our x squareds are going to cancel out, and then we will be left with this. And observe in this expression over here, we have a common factor of h. So factorizing this value of h, we'll get 2x plus 2h over h, which is equal to the limit as h approaches 0 of 2x plus 2h, and as h approaches 0, this will equate to 2x, meaning the gradient function of this parabola will be simply 2x. Sorry if this is not perfectly accurate with a scale-to-scale description of what the curves look like and where they intersect, but that's a rough description. So what does this curve actually mean? Let me repeat myself. If we want to find the gradient of a tangent at any point, meaning the instantaneous rate of change, which is derived from this formula, we can look at simply the y coordinate of the respective x coordinates, and whatever the y coordinate of this gradient function is, that is the gradient of the tangent to that curve.